So welcome you to another session in Frontiers in CFD. So today we are preparing the geometry of 70 cell lithium ion battery pack for CFD simulation. So today's objective is to prepare the geometry of lithium ion battery pack with 70 cell. A slice operation we need to do uh, instead of pattern to prepare each and every individual cell. And the last operation is that is specification of fluid and solid zones on computational domain. So this is the geometry that we need to understand first. We need to understand each and every dimensions of the geometry, and accordingly we can proceed for drawing the 3D geometry with the help of Ansys design modeler. So welcome you all. Today we will see the preparation of geometry for lithium ion battery pack. So first of all we are following this geometry which is in front of you. So we'll try to prepare the geometry with the help of Ansys design modeler. So we'll start with our winch. In that we'll prepare first geometry with the help of design modeler. So let's make use of fluid flow fluent option. In that first we are going to prepare geometry with the help of design modeler. So carefully understand how the geometry is. So slightly visualize it in better way. So this is the whole pack we have. So accordingly we are just going to prepare the geometry. So this is the design modeler. So we'll see the geometry specification. So this is how the geometry specifications are. Based upon that we are going to prepare the geometry. So we need to first create the box. So set the units to mm. Create say box primitive. I will take the box. See the dimensions, that is 257 by, we have to take the whole thing which we are having. So let's have this as x component as 257 and your z. Okay, so 29 29 plus 17 plus 31.75 plus 17 plus 29. So that is total is 123.75. So that is in the other direction. So that is in z direction. 123.75. Okay. So this is how in this direction. Another thing which I want is in the respective direction of z, that is 64 mm. So instead of make it frozen, and let's generate. So this is a one of the pack which has been generated considering the dimension which is 64. So accordingly we have prepared this. Now we have made it add to frozen. So this is your solid. We need this to be as a fluid, so let's change it to fluid. So this is right now what we have the geometry. Now again go back to your C. So this is at a distance of 18, this is also at a distance of 18. So create say primitive, then cylinder at a distance of 18. Z is also you need 18. Take this as 64. Radius will be 9 because 1.8 will be your diameter. So sorry, y component is 0, z is 0, x is 18, z is 18. So let's make this as 0. So you have this is generated here. Instead of add material, I will make it slice material, and then we'll generate the geometry. So this is how the geometry is different here and here. So slice geometry option is been used. One more time, create a primitive, let's say cylinder. Now just see the geometry again. This is 18 and this is your 19.5 as a distance. So second cell will be 18 plus 19.5 as a distance. So that is to 37.5. So create a primitive, make it slice material. So x component will make it 18 itself. Here I will make it 37.5. Y component I will make it 64. Z component I will make it 0. So you will see it is generated here. So you need to select slice material and make it generate. So this is the first one. This is related to your battery pack. So I can rename it, say, as pack. I will rename this, let us say, as cell 1. Now cell 1 should be a solid, so make it solid here. Solid, this one also should be solid because it is your cell number 2. So here put cell 2. So these are the two things which you have generated, first and second. Similarly, create the third one, primitive. Let's take a cylinder. Again, x coordinate will be your 18. Make it slice material available here. Now earlier we had y component 64, so I will put it again as the same. Now x component is we already taken as 18. Z component we need to shift in this direction. So plus 19.5. So this is will be 57. Make it this as a 0 and see it is generated at the third place. So we have generated the third. So let's make it cell, say, 3. Ensure that this is also a solid one because we are going to define the boundary conditions as this one as your fluid zone, then this is cell 1, cell 2, and this is your cell 3. Now one more time, go to the primitive, select cylinder, x coordinate will make it 18. Then earlier we have took 57 plus I will take it 19.5. So z will be 76.5. This will be your 64. Make this is equal to 0. Instead of add material, make it slice material and then generate the geometry. So this is the fourth cell which is generated. So you may denote this again as, say, cell 4. Ensure that this is solid. So this is pack. This is cell 1, cell 2, cell 3 and cell 4. So we have generated 4. So let's go back to your geometry 1, 2, 3 and 4. So we required one more. So let's take it one more time, create a primitive, say cylinder. I will put this as 18. Instead of add material, make it slice material. This to be 64. Make it 0. So earlier we had 76.5. So now it is 19.5. So it will be 96. So let's put z coordinate as 96 and let's make it generate. So it is here. So this will be again, you name it as, say, cell 5. So make this as a solid zone. So in this way the first layer we are, or first the column we are done. So it includes cell 1, 2, 3, 4 and 5. So all these are solid. The pack is we are considered as a fluid. Now let's go with the second one. For second one, it is this first distance is 27.5 and this distance will be your, this was 18 up to this, Now you know this 17. So 18 plus 17, that is the distance we have to took in horizontal direction. So let's take it 18 plus 17. So that is equal to 35. So one more time, create a primitive, take cylinder, the distance will be equal to 35. Instead of add material, make it add to slice material. Then x component is you want to shift it. Okay, we already shifted it in x coordinate. Now go back to your geometry. This is 27.75. So put it z is 27.75. Make this is 64. Make this is equal to 0. So now it will be generated here. So likewise you can see this cell number will denote the name here, cell 6. Okay, so this is a pack 1 2 3 4 5 and 6. So we are done with the 6th one. One more time, just see the geometry. So this is 27.75. This distance between the two cell is 19.5. So 27.75 plus 19.5, that is for the second case. So create primitive, that is cylinder. So 27.75 plus, just see the diagram, 19.50. 19.50. So it goes to around 47.25. This is your z coordinate. X coordinate will be your 18 plus 17, that is 35. So put it 35 here. Make y component as 64. This one to be equal to 0. So it is carefully, it is here. Don't forget to make it slice material. So again you may rename this to, let us say, cell 7. So this is need to be make as solid. This should also be solid. Make it solid. Okay, let's check each and everything are solid or not. Okay, only the pack will be your fluid. So we tried with this layer. Now one more time we'll go to the cylinder. Now what will be the distance in horizontal direction? By default it will be 35. No change in it. Make it slice material. Earlier we have took 27.75 plus 19.5 plus 19.5. So 66.75, this will be your z coordinate. So make it 64 here. Make it 0. You will see it is at the required place. Let's make it generate. So these are how we have generated for the first case. In addition to that, make it cell. Let's denote this as a cell 8 over here. Now again make this as a solid zone. Let's generate the geometry. So now one more time, let's go to the primitive, then cylinder. So by default this will be 35. Now first 19.5 we need to add to for other term, 86.25, that is your this one. Make it this as 64. Make this as equal to 0. Instead of add material, make it slice material and generate. So we have generated at this location. So we need to generate one more. So let's one more time go to the primitive. Let's take it cylinder. By default this will be 35. So we need to add 19.5 in the earlier value. So 19.5. So 105.75. So this is your the last one which is coming here. Make this is 64. Make this is equal to 0. And let's generate. So it is generated at this location. So you may need to give the name also. Say cell 9. Let's say cell 9. let's have the another one as cell 10. Okay, so we are done 1 2 3 4 5 6 8 9. So make this as solid. Last. So likewise we are done with the two layers. One, this is 2 3 4 5 6 7 8 9 10. So the process is same. You have to go carry forward again in the same way, the way we have tried to do right now. Again, so let's go back to your geometry. This from this wall to this center is 18. Then this 18 plus 17 you have took. Now we need to take 17 more. So first it will be 18 plus 17 plus 17. So that is equal to 52. So let's create one more primitive. Let's say cylinder. X coordinate you have to take it 52. So it will be somewhere here. Make it slice material. Z coordinate you need to take it again 18 as per the previous one. This component made to be make to be 64. This component we will make it 0. Don't forget to make it slice material. And so this is how the third one, the third column which has been generated. Let's denote this as a cell 11. Now make it as a solid so as to proceed further. So we did with this one as a solid. Okay, so total we had 11 cells we have drawn as of now, so we can proceed further. Now this is the fixed distance, that is if you go back to your cylinder 11, so that is 52 distance, that will be same now. Only thing what it will add now is your 19.5. so let's go back. So create primitive, let's take it cylinder. So x coordinate will be as it is, so that is 52. Z coordinate will add 18 plus 19.5. 18 plus 19.5, so that is 37.5. So that will be your this coordinate. Make it 64 and then make this as a 0. Don't forget to make it slice material, and let's make it generate. So it is generated here. So let's make it again as a cell here 12. Make this as a solid and generate. So in this way we are generated 1 2 3 1 2 3. Okay, okay, now the 52 distance is fixed. Only thing we are going to add is 19.5 in each of the term. So create, go back to your primitive cylinder, make it slice material, then this 52 will be as it is, whatever the plus distance we will have. Now it will be 57. Make this as a 64 here and make this as 0, and let's make it generate. So this is the third one which has been generated. Same way you may make this as, say for example, cell 13. Ensure that this is a solid zone and make it generate. So this is the third thing which we have done. So one more time, the 52 distance will be as it is, cylinder, make it 52, make it as a slice material, and this component we just add 19.5 to the previous term, so it is 76.5. This component will be equal to 64, this one will be equal to 0. Now let's make it generate. So it is generated here. So let's take it cylinder one more time. Then instead of add material I will put it slice material. 52 will be as it is here plus 19.5, so this will be 96 as of now. This one will be 64, this one will be made as a 0. So slice material and make it generate. So let's give this as a name. to say cell 14. Okay, make this as a solid also. Then this one, make this also as a solid and make it name as say cell 15. Okay, so this is cell 14, this is your cell 15. So in this way I tried to draw with the third column also. Now we'll do one more time the last column, and then we can say the same process can be repeated throughout. Okay, so let's do it for the last. Okay, now what will be your the next point? Next one will be 18 plus 17 plus 17 plus 17 for last one. So 18 plus 17 plus 17 plus 17. So now it is 69. So let's create primitive cylinder. X coordinate will be 69. This z coordinate will be just coming back to your 18 plus 20, sorry, 27.75. First will be 27.75. So make this 27.75. Make it slice material and make this 64. Make this equal to 0. So let's make it generate. So it is generated here. So let's rename this as, say for example, cell 16. Make this as a solid and make it generate. Now this 27.75 is the distance we have took. So accordingly we need to proceed. Now 69 will be common in each of the case. So let's take this as 69. Earlier case it is 27.75. Let's see, plus 19.5 plus 19.5. So 47.25 will be the distance. 47.25. Make it slice material. Then make it y component as 64. This component to be equal to 0. So ensure that it is slice material. Make this as a rename. Say for example cell 17. Make this as a solid zone and let's make it generate. So your distance was 69, that was common. So create one more time a cylinder that is 69. Only thing I will change is this value. So this will be plus 19.5 in the earlier term you took. So this is 66.75. Make it slice material. Then make it 64. Make it 0. And let's make it generate. So this is the fourth one we have got. Let's denote that as, say, cell 18. Okay, so this is the 18 one which we have done. One more time. Okay, see this cylinder 69. So to create primitive, this will be 69 as it is. Z component we will add plus 19.5 to the previous term which we had. So this will be 86.25. Based upon that, this will be 64. This will be equal to 0. Instead of add material, I will make it slice material and generate. So this is a cell 17. Let's make it cell 19. Make it solid. Okay, so one more time, create a primitive that is cylinder. So make it 69 here. So you need to add 19.5 to the previous term. 19.5. So this will be 105.75. Instead of add material, make it slice material. This is to be 64. Makes to be equal to 0. And let's make it generate. So let's last one to be make as a solid. Let's denote this as, say, cell 20. Okay, so this is how the first 4 columns we have tried to do. The same process you need to follow till the end in order to make it as per the requirement of 70 cell. Now let's go back to your geometry and let's see how this can be drawn. So you will see this is distance is 29. After that there is 17, 17 like that. So I will go back to the 3D view for the object again, and I will try to create one more box. Let's say primitive as a box. You might be in position to visualize it somewhere here. Now what is the dimensions of the box? The dimensions of the box are 29 by, it must be 10. So where is 29? 29 is your z component. So make it the z component, let's say it's 29. Okay, so this will be 29. Now the y component will be 64 as it is. So I took this 64 as it is, and your x component will be minus 10 over here, so that it will come on the other side. So you can see here on this side. Now at what distance it is? It is to be, sorry, this distance will be equal to, z distance will be equal to 17, and we need to shift it by 29. So let's make it z is equal to 29. So you can see it has been shifted to a distance that is equal to 29 as for the geometry. So this is one. Again this is at 31.75. So let's make it slice material, sorry, make it frozen now, and let's make it generate. So this is the one we have generated. Similarly I need to generate it on the other end. So let's take primitive, say box. Again the z component you need is just 17, y component you need 64, x component you need it minus 10, so that will be on other side. And how much we need to shift it? We need to shift it by a distance that is equal to 29 plus 17, then 31.75. So let's add it. 29 plus 17 plus 31.75. So that is 77.5. So let's go to the 77 point, that z component, it takes 77.75. So it will be somewhere here. So let's make it add to frozen, and let's generate the geometry. So in this way it has been generated on this side. Similarly you can generate it on the other side. So for this we can make use of the pattern option available. So create, let's say, a pattern. So select the two bodies which we had, this one and this one, make it apply. Direction I will select, just see whichever the direction we required. Okay, this is the right direction, make it apply. Now this is the distance which we have is 257. So let's see whether how much distance it goes by 257. Okay, let's make it generate. Okay, it is on this side, so you need to add it 257 plus 10, that is equal to 267. Let's make it generate. So now it has been generated on the other side. Now ensure that this is the pack which we had. So this is solid, so we need to make it as a fluid because it will be the pack for your geometry. Same way this will be also need to be fluid because this is a portion where the fluid is likely to flow. The last one, let's make it fluid. So you can rename this as a pack also. So let's, what we'll do is I will go to one operation which is called as boolean. So let's make this as a unite option, this one and this one, make it join, and let's take it generate. So you can see now this is actually the part of the object, so that is defined as a pack and remaining defines as a cell. So you can proceed further to the way the process has been followed for, let's say, for first 4 levels of such columns. Similar process can be followed it for the remaining, and accordingly you can prepare the 70 cell lithium ion battery pack. The why the purpose is done as slice material, so that the identity of the cell will be uh, proper when we are applying the boundary condition, and that's why this is very important to slice the material rather than using the pattern option for generating such kind of cells. So this is how the objects that are being prepared. So all the cells, they are a solid. Okay, this is one fluid, make it solid. Yeah, all cells should be solid. Ensure that each one of them are solid, otherwise there will be errors in the boundary condition which we are applying. So let's take a quick look of whether the cells are solid or not. So almost everywhere we are done in the right way, and the pack will be your fluid zone. So in this way the geometry can be prepared.